So question 5A from AP Classroom. I'm trying to get to the answers down to the bottom of these. So if you haven't heard how to do some of these problems yet, this is a good way of figuring it out. First off, part A, they're asking for concavity. Concavity is all based on your second derivative. If the second derivative is positive, then it's concave up, and if it's negative, it's concave down. Here's where it really helps to have a graphing calculator. Because what you need to do is actually graph the equation and find out where these are going to be equal to 0 or greater than or less than to 0. So if you can find those exact points, you will be able to find out where it is concave up. So as you saw by the graph, if I took a moment to find the actual zeros, I had zeros at 0 and these other 3 points. 3 is just the end boundary. And to get the zeros, I use the function on the calculator that is 0. Go to second trace, which is the calculate area, and I believe it's number 2. Make sure you round to 3 decimal places or truncate. In fact, this number here could be 2.171 also. That is also acceptable. But we know where it's concave up because that is where the second derivative is positive. All the hard work should be done by your calculator. And so the final answer is given there in red, and the reason you would give is because the second derivative is positive, meaning that it is concave up. The sign chart helps with this, but it is not a justification. You must provide the sign chart and say something else about it, like telling me that is the second derivative, and the positive parts are where it's concave up. For part B, we're supposed to identify whether 1 is a min, a max, or some other point. Well, if the first derivative is 0, which it states in the instructions, that means it is a critical value, meaning that should be a minimum, a maximum, or maybe an inflection point. But when the second derivative says that it is concave down, that means any critical value on an area that is concave down is a maximum. So you would need to state that x equals 1 is a maximum because it is concave down on that interval. That should be enough. For part C, you're supposed to use the mean value theorem to prove that f prime of negative 1 can't be 2.5. So first, a quick review of the mean value theorem. You are showing that the average rate of change of a function, in this case f prime, would be equal to its derivative, f double prime, at some point on that range from negative 1 to 1. You also must know that it is differentiable. And since it stated that this function was twice differentiable, we're all good there. So we plugged in the actual numbers, 1 and negative 1, and then we knew that f prime of 1, it was given in the instructions at 0, and they're saying that f prime of negative 1 can't be 2.5. Well, if we just do a little bit of math here, theoretically we're saying that it can't be equal to 2.5, so those can't be equal to each other, which is quite true, and there are 2 ways of knowing this. 1, if x is between negative 1 and 1, the biggest that x squared can be is a positive 1. Any other number than negative 1 or 1 going into this is going to make it smaller than 1. And the next thing to know is that cosine, the biggest value that will ever be is positive 1 to negative 1. It never gets larger. So the biggest that this could be is 1, and the smallest it could be is negative 1. That gives us some kind of boundaries to work there. Now, if you weren't comfortable knowing that, you can always go back and look at your graph to see what that graph looks like from negative 1 to 1. You can find the minimums and maximums by looking at the graph on your calculator. So part D should be really easy if you still have your sign chart from the second derivative. Once again, you have to explain it is the second derivative. The sign chart alone is not enough, but you can say there is no inflection point at x equals 0, because obviously the concavity does not change. It goes from concave down and continues being concave down there. So you can either state that the concavity does not change signs from positive to negative, or vice versa, or that the second derivative doesn't change signs. Either way, this proves that that is not an inflection point at x equals 0. And there you go. That's how you can do all of AB Classroom question 5A correctly. Thank you.